Okay, today we're going to talk about section 3.5, which is slope-intercept form. So let's go over slope. So probably the biggest thing we need to talk about is slope. We have a couple formulas. So slope interforms this. The other one is called slope of a line, which looks like this. M equals y2 minus y1 over x2 minus x1. And this equates to rise over run. So when you hear me talk about rise over run, remember that indicates slope. Slope can be read in several different ways. It can be read in an equation. So if you have an equation set up where it's solved for y, then slope is going to be indicated with the x. If you have slope in standard form, so 3x minus 2y equals, let's just say for giggles, 8. And I ask you what slope is. You cannot determine slope in this form. It has to be solved into slope-intercept form, which is why we're talking about slope-intercept today, because of that reason. So we solve the equation by subtracting 3x across. So negative 2y equals negative 3x plus 8. And remember, the plus 8 comes because 8 is positive. So therefore, it's going to be positive here. And then divide everybody by negative 2. So y equals 3 over 2x minus 4. So your slope, once again, is whoever is tied with x after it is solved for y. So remember, these are slopes within an equation when you are in slope-intercept form. If you are given two ordered pairs, so let's say I give you two ordered pairs, like negative 2 comma 5, and let's say I give you negative 8 comma 13, just for fun. So first thing you need to know is the formula up above is what we're going to use here. So let's take and label these. This is x1, y1, and x2, y2. If you notice, the first order pair, I put a 1 indication, the second one a 2, so that it will denote with the formula itself. So we draw our line. You put your y2 first, which is 13, minus whatever y1 is, which is 5. On the bottom, it's negative 8, minus the other one, which is negative 2. If you need to see it in parentheses, that's fine, but don't forget that just because the number's negative, doesn't mean that counts as your subtraction sign. All right, so let's actually work this problem out. 13 minus 5 is 8. Two negatives make a positive. So I'm going to have negative 8 plus 2, which is negative 6, which reduces down to become 4/3. And it's going to be negative 4/3. All right, so this is how I get my slope with an equation. And this is how I get the slope with the formula. All right, so I'm going to tie these two together here so that you can see that's what's going on. So the first two is getting slope using the equation. The second two is getting slope using the two order pairs. Let me show one more example. Let's say I have 0 comma negative 8, and I have 16 comma negative 9. First thing again, we label them x1, y1, x2, y2. I will say this. I know I normally get the question, does it matter who is x1 and who is y1? Or sorry, who is x1 and y1 and who is the x2 and y2? The answer is no. If you want to make these the 2's and these the 1's, it really does not matter, folks. What matters is that you stay consistent. So once we label that, we're going to go over here and say y2 is negative 9 minus negative 8. And then I have 16 minus 0. Two negatives make a positive. So I have negative 1 over 16, which is my slope. And by the way, you're going to see that M denotes slope. Someone asked me what it stands for. Basically, just think of movement. That will help you the most because slope is all about movement. All right, so we've gone over the definitions. We've gone over the equations. So let's start working with how to graph these. So when I go to the next page, which is going to be on page 82, we're going to talk about what the slopes mean. Just because I have them here, you can see they're positive and negative, but when you're on the graph itself, let's go over that we know what kind of slopes they are just by looking at them. So a positive slope, I'm going to make little T-charts here. I know they look like big plus signs, but you know, hey. So let's talk about positive. So if it's a positive one, it's going to be moving low to the left, going up to the right. So low left, if it's reading left to right, it's going up. So you should be seeing slopes growing like that. Okay? If it is negative, negative means I was high to begin with and now I'm low. So in other words, it's the reverse. I am decreasing over time. This would be an example of a growth of a stock market. Think of this as, say you're doing weight loss. That's a better way to think of it. Weight loss over weeks. So that would help you with this one. That would probably look more like a scatter plot, but let's just play along. That's something that thinks with us. So 0 is the next one. So slope of 0 is actually just a horizontal line. So you're just going to go horizontal with that. There's nothing else. And with undefined slope is going to be a vertical line, straight up and down. Once again, that's just by definition. So you should be able to look at the way the line is going and tell whether it's positive, negative, 0, or undefined. You do not need to see the actual numbers to make that decision. Okay? So that's the first thing you need to remember. Now, writing stuff in slope-intercept form. So let's talk about how to do that. I am going to jump right to page 83, exercises 6 through 8. And I'm going to ask you to solve this so that we can see what the slope is. So if we have, for number 6, we have 6x plus 4y equals 24. I want to know two things. What's my slope and what's my y-intercept? So over here, I'm going to put m equals, and I'm going to put b. B stands for the y-intercept. So make that notation off to the side. This means y-intercept. In other words, where I cross the y-axis, if you remember from the previous one. M stands for slope. Those two are constants. You don't have their constants, meaning they don't change. Once you get them, those will be graphed. Now, I need to be careful with the word constant, because constant usually means it's something that never changes. But in the formula itself, M will always be slope and B will always be y-intercept is what I was getting at, a constant. All right, so let's go ahead and make this. I'm going to solve for y. So if we're in standard, which is what we had last section, we're going to solve for y. So I'm going to subtract 6y from both sides, or 6x, apology. So 4y equals negative 6x plus 24. I'm then going to divide by 4 across the way. So y equals negative 6 over 4x plus 6. We do need to reduce our fraction here. So this is negative 3 over 2. So my slope is negative 3 over 2. The b is always in the back without a variable attached. So the b is going to be positive 6. That is my intercept. Okay, look at number 7. Take a moment. Let's look at number 7. We have y equals negative 3/4 x plus 2. My question to you, are we already in slope-intercept form? Have you had time to think about it? Good, you're correct. We are in slope-intercept form already. So the first thing we're going to do is just label them. So b is going to be 2 and m is going to be negative 3 over 4. All right, number 8 is my last one. Y equals 5x. So for this particular one, it's the same thing. This really is written in slope-intercept form. What throws students off is there's no plus b. You need to see this as plus 0. So your b is 0. So in other words, I am going through the origin because I am not moving up or down on the y-axis. I am right going through the origin. So this right here for my slope is 5. All right, so now that we've covered with that, with what we did with the slope-intercept form, locating slope and the y-intercept, let's step up to back and go back to 1 through 3. So for 1 through 3, what I'm going to do here is show you how to get the slope of the line without having to take and do the math. It's still doing math, just not writing out the equation. So let's take and label these. So the first one is one of our specials. We said if it's going straight up and down, it is called vertical. Which one's vertical? Ah, you're right, undefined. So this is undefined slope. Remember the hint, it's vertical. So what type of slope is this one? Good. This slope here is going to be positive. To get the slope, we have to do one of two things. You could either use this formula that we just did, or you could take and do some counting. So if you have 2 ordered pairs given, you can take and start here and do rise over run. So if we have this 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to rise 8, and we are going to run starting from this point over 1, 2, 3, 4. So 8 fourths we know to be 2. So my M is 2. With me so far? Good. Last one, I'm going down. So we know this is going to be negative. Let's get slope. So we're going to start here and we're going to count up. 1, 2, 3, 4, 5. So my rise is 5. My run is back, which is 1, 2, 3, 4, 5. So it's negative 5 over 5, which we know to be negative 1. So M equals negative 1. All right, so using the graph, you can use counting. So remember, when you're going up and down, this is rise. When you're going left and right, this is run. So I will label both of these. Now, this particular one is by definition, so you're going to have to just remember that one by definition. Number 4 and 5, last two for this one, and then we'll talk about number 9. We want to get what the slope of this line is. You select an ordered pair. This one here, if you look at these, let's just select these 2 here. Okay, I'm just going to pick 2. So this is going to be my x1, y1, and this is going to be my x2, y2. So I'm going to have negative 2 minus a negative 2 over 3 minus 1. So two negatives make a positive, so I'm looking at 0 over 2. 0 over 2 is 0 slope. 0 slope is just that, 0 slope. So that is your answer, M equals 0. Which in case makes a horizontal line. So let's look at this one. I'm going to select these 2 here, just because. So I'm going to have x1, y1, and x2, y2. So I have negative 13 minus 11 over 3 minus a negative 3. So I'm looking at negative 24 over positive 6. So I'm looking at negative 4. So my M equals negative 4. All right, so are you with me so far? Excellent. Last problem. A linear function f models a relationship in which the dependent variable increases 6 units for every 3 units the independent model decreases. The value of the function is 0 is 4. Okay, so what we're saying here is we're going to make a model. So for the dependent decreases 6 units for every 3 units the independent. So dependent is y. Remember we talked about this, and independent is x. So when we're looking at this, we're going to have to get slope. So m equals 6 over 3. And it decreases, which means it goes down for every for every 3 units, the independent variable decreases, which means going back. So it's going to be negative. So we're looking at -2. The value of the function at 0 is 4. So what I'm saying is when I have 0 for x, my y is 4. So b equals 4. Okay, I took a moment and checked, and slope is actually a positive 2, because if this is decreasing and this is decreasing, 2 negatives make a positive. So that's one thing we have to be careful with. All right, so we have this here. So what I actually have is y equals 2x plus 4. So let's graph this. So I have this right here as being 4. We can go in the reverse. So if we decrease 6, like it says, so go down 2, 4, 6, and back 3, there's my order pair it's talking about. So when I draw my line, I am crossing the x-axis, or the x-intercept, at -2. All right, my y-intercept, which we already indicated when we said it was b, is 0, 4. So these right here are the things that we're looking for: slope and the 2 intercepts that it asks for. And like I said, just be careful, because I just about tripped up on that with the -6, decreasing 6, and decreasing 3 as it went down, because it said every 3 units the independent variable decreases. That's where I made my mistake as well. All right, so that is the end of this video. Make sure you get started on your homework right away. I will post other videos that are by different instructors but covering the same thing, so that way you can have a different opinion. Good luck on your homework. If you have questions, you know how to get a hold of me.